This is a true story about Mr. Steve Walker, who happens to teach BC Calculus at McLean High School. And although Steve swore me to secrecy, I am revealing this story to you once again because I am deceitful. Yesterday, Steve and I took a trip to the Washington Monument. He wanted to see if he could derive a volume formula for what he referred to as the magic obelisk, and he thought that I could perhaps help him. We drove my sporty Audi Q5, which has finally been repaired from the gas tank incident from last fall. And even though the monument is still closed due to elevator issues, Steve was undaunted as usual. He convinced me to sneak past the guards and enter the monument, and then forced me to climb all the way to the top. He was so excited by the view of Washington that he leaned out just a wee bit too far and fell all 558 feet to the ground. Now, don't get mad, Steve, but I must disclose that you were wearing a rubber suit that day because you were having delusions of being Spider-Man and scaling the monument. Because of that suit, Steve was not even bruised when he hit the ground. He had a tiny scratch below his right eye, and he easily covered up with a bit of makeup from his wife's purse. We'll say that his wife, Megan, gave this to him. So I said to myself, won't this make an interesting calculus problem? So let's work through these, and we're going to have to show all of our work. So the first question is, how many seconds elapsed before Steve hit the ground? And it's stunning that you actually do have enough information here because Steve fell out of the Washington Monument, so gravity is pulling him to the ground. So I start with my dv dt, which of course is acceleration, due to gravity. And I circled as I went through here the 558 feet because that tells me that dv dt is going to be negative 32 feet per second squared. It gives me the units that I need to work in. And now I can integrate dv dt to get that velocity is equal to negative 32t, and I need a plus c here. Except for he fell. I didn't push him, so my plus c is actually an initial value of 0, so velocity is just negative 32t. So now I'm going to integrate velocity to get to position, and remember we use s for position. And when we integrate, we go up a degree to 2 and divide by the new degree, which gives me 16t squared. And now I need a new plus c, so this will be my plus c sub 2. So what is Steve's initial position? Well, again, that 558 feet is all I needed because now I know that he started 558 feet off the ground. So then you have to say, okay, how many seconds elapsed before Steve hit the ground? Well, you can go ahead and put this in your calculator and solve, or you could do a little bit of manipulation here. You're going to get negative 558 equals negative 16t squared because, of course, when Steve hits the ground, his position is going to be 0. And then you can divide both sides here by negative 16. So my t value is going to be the square root of 558 over 16, and again, you can put that in your calculator to determine an approximated value. And of course, don't forget that you need 3 decimal place accuracy, so I get 5.906 seconds. Okay, so the next question is, at what velocity was Steve going when he hit the ground? Well, I can take my 5.906 value for the time that passed and plug it into my velocity equation. So the velocity at time equals 5.906 is going to be negative 32 times 5.906. And when I multiply that out, I get negative 188.976 feet per second. And don't forget, you should be in 3 decimal place accuracy all the time. Okay, so now, since we don't really know off the top of our heads how fast this is, number 3 is just a little bit of a conversion problem to find out how fast he was really going. So negative 188.976 is, of course, in feet per second, and we want to convert this to miles per hour. So I know that 1 mile is 5,280 feet, and then 3,600 seconds constitute 1 hour. So this will let me cancel my feet, and it will let me cancel my seconds, and my units will be left as miles per hour. And when I multiply this out, I find out that Steve was going negative 128.847 miles per hour. That's fast.